is equal to R0. This is more like at 0 degrees. Bracket 1 plus alpha T. Sometimes they use change in temperature, but alpha T is fine there. Now I'm just going to work this faster. Why? Because the units are already good for me. Look at this, the temperature coefficient, this is RT. Okay, let me write temperature coefficient is your what? Is your alpha there. And then per ohmmeter has a resistance of what? 15 ohms at 0 degrees. So when they give you 0 degrees is your what? Is your R0. There is the ohms at R0. So if they link the ohms at 0 degrees, just know it's your R0. Why? Because it's the initial R resistance. And then there is temperature is increased. This is our T. See that? Then we can apply our RT as what? 15 bracket 1 plus 0,0058 times 50. Hello, our most developed student. My name is Confident and welcome to the continuation of the ultimate guide, a 13-day intervention in your industrial electronics, where you will learn everything that you need to know about industrial electronics. So these are the topics that I'm going to be covering in this intervention plan, and already we have looked at two modules. Now we are looking at the third module, which is the resistors, but this is part 2 of that. So if you have not watched the first part, I will encourage you to do that now. What are we doing here? We're going through every module to prepare you for your final exam, and already look at the questions that we're bringing in. These are questions like previous exam papers. I just pulled them from there, and I'm showing you the solutions you needed to do. Now sometimes they repeat these questions, so this is what is going to assist you as you prepare for your final exams. So we have already in the previous video done 3.1. You can see the working of last time. 3.2, we did all these. 3.3, 3.4, we're working on these. And then let's move on. Let's see 3.5. we did 3.5. now we are looking at 3.6. let me just verify this to see. Yes, we did this one. Now we're looking at 3.6. If this is your first time coming in contact with this channel, definitely you need to make sure that you are subscribed so that you're not losing any important video. Okay, 3.6, it says a copper conductor has a length of 50 meters and a diameter of 6 millimeters. Determine the resistance of this conductor if it has a resistivity of 0,18 micrometer. Now I say to you, whenever they are giving you questions, you need to know of these questions, which formula am I gonna apply? Look at this. And I say be sensitive when you're dealing with resistance. 2 formulas are in place, the first one and the second one. Now the first one deals with temperature. When you hear about temperature, the second one deals with length and area. So when they talk about length and area, just know you are dealing with the second one. But here they say what? Length. So automatically you know which formula to use, and it is this formula. R is PL over A. So let me write that formula down. It says resistance R is PL over A. But now you need to convert this information that they've given you so that you can plug it into the formula. We have done a similar question like this. If I were you, I will pause this video, work this question out, then compare my answers against mine so that you can see if given an exam, can you do that? It's like, all right, so let's do what this question requires. First things first, the conductor is what? Length, which is our L, is 50 meters. Are the units the SI units? Yes, you must always make sure that you are in meters. But look at the diameter now. Something is wrong. Diameter is in what? 6 millimeters. And I said you need to take your millimeters, you divide by 1,000. So 6 millimeters, you divide by 1,000. You are converting them to what? To meters. Either you multiply by 10 to the power 3, negative 3, sorry, 10 to the power negative 3, or you divide by 1,000. this will convert your 6 millimeters into what? Millimeters, which is what? 6 times 10 to the power negative 3. See, it's more like you're multiplying by 10 to the power negative 3. This is now in meters. Now, I also mentioned that whenever they give you the diameter, you must always know that you convert the diameter to radius. So what is the radius? The radius here is equal to, take the diameter, you divide it by 2, which is equal to 6 times 10 to the power negative 3. Then I divide it by 2. When you do that, 2 into 6 is 3. So it will give you 3 times 10 to the power negative 3. This is your radius, r. But now, why are you doing that? You want to check now, you are not given the area. Remember, they gave you the length, they gave you the radius, but why are you doing it? So that you can say my area A is pi r squared, which is equal to pi times your r you are given now, put a bracket, and then which is 3 times 10 to the power negative 3, and then you square that. That's the most important thing. And then lastly, what did they give you? They gave you the resistivity, which is your P. This becomes your P, resistivity. Then it's 0,018 micro. Look, something wrong again. So they gave it as what? Let me find some space here. Let me do it this side. They gave it as 0,018 micro ohm meter. Now micro is a problem. You can't work with micro. What do? You take that micro and then you say 0,08, you divide by 1 million, you see, or multiply by 10 to the power negative 6. This will convert it from micro to just ohm meter. So what do you have? Once you do this, guys, this is your housekeeping rules. You are just trying to set up your question to be ready to be plugged into the formula. So this is what? 0,018. We are dividing by what? A million. 1, 2, 3, 4, 5, 6 equal to 1,8 times 10 to the power negative 8. See, now it's ohm meter. You have removed that micro. When you do this, you are ready now to plug it into this formula. So what does it say? If I can put it here in the center, this is our formula here. And then what do? We say R is equal to P, which is just what we wrote here, 1,8 times 10 to the power negative 8 times the length. They gave us the length, which was 50 meters, divided by what? Area. Now you can simplify, you can find your answer here, but it's good to write it as is. Pi bracket 3 times 10 to the power negative 3 squared. It will just give your resistance straight away without you having now to be rounding off that side and coming back and finding the answer that side. I prefer this, but as I said, it's up to you how you want to do it. So you do that and you're going to say 1,8 times 10 to the power of negative 8 times 50. Just make sure that you are multiplying properly there. Divided by is it shift pi times bracket 3 times 10 to the power of negative 3. Just be careful how you do this, and then you put squared there, equal to, there is the resistance. I hope I did also right there. What is the resistance? Is 0,0318. In 3 decimal places, 0,032 ohms. 0,032 what? Ohms. Alright, so that becomes the what? The answer to this question. As I said here, use the formula, convert everything that you are given so that you can be able now to work this out. Now moving on, let's check the next question here. The next question is 3.7. It says a conductor with a temperature coefficient of that has a resistance of that at that. Calculate the resistance if the temperature is increased to 50 degrees. Now I'm going to pause, or allow you pause this video. We have done similar videos in video number 1 in the first part 1 of this lesson. Work it out yourself, then compare your answer against mine. Now, what is the hint? I said when they say a conductor with a temperature coefficient, okay, fine, and then has a resistance, okay, fine, but the moment they mention this word temperature, you know which formula to use. You go to these two formulas and you can see there is only one formula with resistance and temperature. It is that one, where T is the temperature. So come here, you write that to say RT is equal to R0. This is more like at 0 degrees, bracket 1 plus alpha T. Sometimes they use change in temperature, but alpha T is fine there. Now I'm just going to work this faster. Why? Because the units are already good for me. Look at this, the temperature coefficient, this is RT. Okay, let me write temperature coefficient is your what? Is your alpha there. And then per ohm meter has a resistance of what? 15 ohms at 0 degrees. So when they give you 0 degrees is your what? Is your R0. There is the ohms at R0. So if they link the ohms at 0 degrees, just know it's your R0. Why? Because it's the initial R resistance. And then there is temperature is increased. This is our T. See that? Then we can apply our RT as what? 15 bracket 1 plus 0,0058 times 50. And then you get your answer in ohms. Don't forget to leave your answer in the right units. What is the answer? It is in ohms. So let's do that first. Then there it's 1 plus 0,0058 times 50. Then we get what? It'll give us the resistance, which is 15,435. 15,435 what? Ohms. Don't forget that. Units are very important. 3 marks. Next one. A copper conductor is 70 meters long. See now, length, and has a cross-sectional area of 4 millimeters squared. What is that cross-sectional area? A. The resistivity of copper is this. This is ohm meter. I like the units are already in the right form, ohm meter, but this is what resistivity, which is your P. Calculate the resistance of copper conductor. Now you just saw that they were talking about length and there it is an area. So what do I say? Please do this question on your own. After doing the question on your own, compare your answer against mine. So resistance is PL over A. But now there is only one part whereby they wanted to trick you so that you can get your 3 marks. Everything is set up. Look at it. The length is in meters. The resistivity is in ohm meter, which is P. But now the problem was the area. The cross-sectional area was in millimeters squared, which is a problem there. What do? This is how you convert it. Look, it's 4 millimeters squared. I'm just going to show you. I told you if they give you millimeters, to convert to meters, you divide by what? You divide by 1,000. Then you have got meters. But now they gave you not only meters, but they squared it. So if they square here, you also square there. Then you get meter squared. Do you see what I just did? That's how you convert it. If they square, you square like that. So they gave me what? 4 millimeters squared. Then it will be like that. Let me repeat again so that you can see what I mean. In essence, you're just dividing by a million. But this is this. They gave me 4 millimeters squared. But I told you to convert millimeters into meters, you divide by 1,000. You agree with me? But now, when I square here, so that it can be now millimeter squared. It means I must square also that side to get square meters, but now I can convert that. Are you with me? So it's I can write that answer now to say what is 4 divided by 1000 squared, which is what? Press SD. 4 times 10 to the power negative 6. So this is 4 times 10 to the power negative 6 meters squared. So now we can simply write the answer now to say resistance is P, which is 1,728 times 10 to the power negative 6 times the length, which is 70, divided by what? 4 times 10 to the power negative 6. Are you seeing that? Then it will give us the answer. What is it? It's 1,728 times 10 to the power of negative 6 times 70 divided by 4 times 10 to the power of negative 6. If I didn't make errors in entering those units there, which is 30,24. So R is equal to 30,24. Don't forget the units of resistance is in ohms. Alright, no time to waste. Move on to the next one. What is the next one saying? It's saying a tube filled with mercury has a resistance of what? There it is. At 0 degrees. The moment they give you this 11 at 0 degrees, they are talking about temperature. Now temperature and resistance, and at 0 degrees it's your R0. You see that? At 0 degrees. The temperature coefficient of mercury finds that if the tube is heated to 30 degrees, what is that? And you can see the formula already. It is this formula where they talk about temperature. Which one is this? We are here. So let's write that formula to say RT is equal to R0, 1 plus alpha, or coefficient of what? Of temperature, times T there. Are you with me? Then the question is, if the resistance is this, what will be if the tube is heated? So they want you my RT as R0. They gave me 11, 1 plus coefficient of friction, which is that one, 0.0042 is already done. There is no micro, there is no milli, so it's already done. And then multiplied by my temperature, which is 33. Then that's it. See, guys, it's better for you to work these things out yourself now. If you see the question repeating, don't just watch now. Don't be a spectator. Be part of the video. Watch, work it out, and then what do you do? 0,0042 times 33. So that you can compare your answer against mine, 12,5246. I told you how to round off. Shift, setup, 6, and then 3 decimal place, which is 12,525. 12,525. What are the units, guys? Ohms. Now look at it. It must always be at a higher temperature, because at initial temperature of 0 is 11. Now at a higher temperature, 33 degrees, it's 12. Why? Because the resistance increases with an increase in temperature. Remember, it's one of the factors. Alright, next one. A round copper conductor with a diameter of this and the length of this has a resistivity of this. Determine the resistance of the conductor. Now they are also talking about what? The diameter here, 6 marks. The length here is in kilometers. Look at this, millimeters. Now it's kilometers. The resistivity is in ohm meter. Now determine the resistance of the conductor. Could you have done this? You know the formula. What is it? I'm not going to work it out, but I'm going to just prepare this for you. R is equal to P what? L over A. That's what you're supposed to use. But now what is what? There is your P, but your P is not the right P. What you need to do is to convert it. So what is it? Micro. What do you do? 0.0042 0.0177, that's my P, 0.0177 micro ohm meter. I say divide by a million. Micro means divide by a million. You are going to convert it now to ohm meter. Are you getting that? So you'll get an answer for P there. Next one, look at the length. Length there again is in kilometers. 0.5 kilometers. You can see this is long. You multiply by 1,000 now. You no longer divide. Why? Because we are working with kilometers. Then it is going to give you again an answer. Now the length, okay, the diameter, they gave us the diameter there, and I told you when they give you the diameter, you must first convert the radius and diameter together. So you know what is it? Radius is equal to diameter divided by 2, right? Which is equal to, what's the diameter? 6 millimeters divided by 2, which is equal to 3 millimeters. But you need to convert that 3 millimeters. So the radius is equal to 3 millimeters. You divide it by 1,000 and then you get that answer. So when you take the answer that you get here, you take the answer that you get here and take the answer that you get here, you can now plug it into your formula here for resistance. You must be able, oh, no, stop it. You know what I did wrong, right? The part here is not done. You first need to say, okay, since I've got my R, I must find my area. What is area? It is equal to pi R squared, which is equal to pi times, then you take the answer here, you put your R squared, then you get your A. It is the answer that you get here, which you must put in here for the A. Now, let me give you a heads up. If you struggled with this question, you just need to give me feedback to say, there is 3.10. I'll remember this question 3.10. If you are struggling with it, just say, please do for us 3.10 on resistance. I will know that it was a challenge for you. But I was trying to prepare this for you so that you can be able to see how to go about to get this 6 marks. Let's move on to the next one. Alright, just before I move on to the next one, a quick one, guys. I think I've already shown you in the previous video to say this video or the videos that are going to be following on industrial electronics, they are sponsored by Eguru Learning Technical College, one of the most leading colleges in correspondence learning, distance learning, offering N1 to N6, and you can see the courses they are offering. You can check their brochure on their website there, www.etcollege.co.za. and as I say, they offer things from installation rules, the engineering courses, as well also as business courses. They do offer them, and also as you can see, this is mainly in distance learning, and these videos that I'm doing and the other videos of maths and other subjects, but they will tell you the subject that they've got videos, they offer them for students who are also doing their distance learning. All right, so now if you're interested, just check their courses there. Let's move on to the next lesson. The 3 resistors with the following values are connected in parallel to a 50 volt DC supply. So now we're in resistors. Now it's a different part of the lesson, which though is still talking about resistors. But now I just want to be clear here. I'm just introducing this topic on resistors in series and resistors in parallel. There is the topic of direct current, whereby we're going to be calculating, if you still remember, or remember, this is revision, so you must be remembering this. If you remember now that resistance is equal to V is IR. Resistance is voltage over current. Remember, find voltage, find current, find resistance. So this lesson though doesn't cover that part, so you must see the continuation later when you talk about direct current. But for now, I just want you to appreciate the understanding of resistors in series and parallel. 2 questions that I brought so that they can add value as you prepare. 3 resistors with the following values are connected in parallel to this. So these are the resistors. So what do they mean? If I can quickly sketch this, these resistors, what you have a resistor 1, you have a resistor 2, you have a resistor 3. So there it is. So what is this? This is your R1, it's 15 ohms. Your R2, it's 20 ohms, and your R3 is 30 ohms. And then they're saying they're connected to what? They are connected to a 50 volt DC supply. So in here you have a what? A 50 volt. Are you with me? And then look at this. It says calculate the total resistance in the circuit. Now formulas, guys, always rely on the formulas. Let me go, Charlie. Where are my formulas? Let me come back to this. So these are my formulas for the resistance. The resistance in series, you remember, if the resistance is in series, you just add like this. This is for series. And you know series is one after the other. These are resistors in series. But in parallel, the one that we drew, this is the one that we're going to use. So I'm going to use the one here to say the resistance here. Look how I'm going to write it, because it's very important for you not to miss things here. It's 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3, right? So we can say 1 over RT is equal to 1 over R1. If you can just cut that, is what? 15 plus 1 over 20 plus 1 over 30. I know it looks simpler, but this is where students mess up. Please, for you to avoid errors, just this, then do this. Say therefore RT is equal to 1 over, and then you say 1 over 15 plus 1 over 20 plus 1 over 30. I know you're going to say why. I'll show you just a little bit of mathematics there. But if you do this, don't forget, say 1 over, and then you repeat this. But after saying 1 over, and also you're no longer calculating 1 over RT now. And please, when you cut the formula, you started by saying 1 over RT. Also maintain it here. It's still 1 over RT. Don't say now RT is equal to. No, you are still looking at 1 over RT. Are you with me? But if you want to write now from this to go there to say RT, that's why you say 1 over, and then you maintain that. What is now my RT? And then with the calculator, that's what you're going to do also. You are going to say 1 over. So you put a fraction, 1 over, then you put fractions at the bottom, which is 1 over 15, play forward, plus what? Fraction again, 1 over 20. Be careful how you put these. Just need to be careful. Also practice this, plus 1 over 30 equal to 20 over 3 SD 6,667 what? Ohms. Now, just a little bit of math. Some of you were asking, what was I doing there? When I was doing this, I'm saying 1 over RT. You saw what it gave me. It gave me, check with your calculator. When you just add these, you're going to get 3 over 20. That's what it will give you. That's not your answer. Now what you do, you are allowed then in mathematics, take this to the top, this one to the bottom. So you will have RT over 1. This is 1. Actually, not I. RT over 1 is equal to what you do on the left, you do on the right. So 20 goes to the top and 3 goes to the bottom. That's why you saw me having that answer of 6,667. This is what you're going to get now and say RT over 1 is simple RT, which is 6,667. Perfect. Now, last but not least, a very important one, figure 1, refer to figure 1 and determine the values of each. Calculate the total resistance of the circuit. Guys, look at these 8 marks and you're supposed to find the total resistance. Total resistance. You need to know what to do given such a question. In this lesson, I'm going to show you how to approach such. You're not going to struggle when it comes to answering such questions. Alright, so let's get into this lesson. What do you do here? Follow up your, I will say follow up. I know some people will say there is conventional current and then there is the flow of electrons. So I'm going to use the conventional current method to say, if this, it doesn't matter, whatever way, you're still gonna get the same answer after all. So look at it. If this is my positive and this is my negative, let's say I'm following with the conventional current. This is my I coming in, this is my I. When it comes there, you agree with me that current is going to split. Some of it is going to come here. Let's call it I1. And then some will go straight. Let's call it I2. Right? So I2 will come out here. And I2 is going to further split into I3. And I3 is going to split into I4 because this goes into I4. See, I'm following current. From here, it becomes I4. From here, it becomes I3. But from here, they are going to combine. I4 plus I3 will combine, Kirchhoff's laws. When they combine, they return back to I2. Look back. It was I2 that split. After combining, we're back to I2. But I2 is passing through I5. You see? It's I2 or I5. It's the same. Whether you say I5 or you say I2, it's still the same current. And then further, it combines here to give you your I, which is we call it I total. Let's call it IT. This becomes now IT, which enters here as our IT. So now, when you have gotten this, what it means is, let's look at the splits. The last split is the most important. Look at I2 becoming I2 back. Then it means we need to focus on this guy. You see what they are? They've got I3 and I4. First of all, let us add them. And what type of resistors are these? These are resistors in what? These are resistors in parallel. I3 and I4. When current split, it means they're in parallel. When they're in parallel, we use the parallel combination, which is 1 over R parallel is equal to 1 over R what? R3 plus 1 over R4. So 1 over R parallel there is equal to 1 over 6 plus 1 over 4. And I told you what to do. When you want to change now to say what is R parallel, you want to get the answer directly, you say 1 over 6 plus 1 over 4. You see that? Then you take a calculator, it will give the answer straight away. Alright. So this is fraction 1 over 6 plus 1 over 4 equal to, I'm getting 12 over 5, which is 2,4. So this is equal to 2,4 here. 2,4 ohms. So what am I having? I'm having my new diagram. I just want to draw it on top here. You'll see the new diagram. My new diagram, that is after this. I'll have a new diagram like this. Let me use something different. I'll have a new diagram like this. This new diagram will have a new resistance like this. And then it continues. But now don't forget, these don't exist anymore. This is gone. Put an X. This is gone. Put an X. So now this doesn't exist. So the new diagram is the one that I just drew. So if I can make it even more bolder, I'm saying this is our new diagram. This one. And then it joins the rest. But now look at this. when you follow the flow of current, this is still my I2. This is my I2. Now this is my I2 going into I5. Now look at this. The resistors here, this resistor R2 has got the same current as this resistor, which is a combination of that parallel, as this resistor. So do you see that these resistors are now in series? Meaning I've got a series combination, and that series combination will be RS is equal to, then you take what? 8 ohm plus that 2,4. So it's 8 plus the answer we got on that parallel, 2,4, plus this R5. So let me actually call them, let me write them, the names. RS is equal to the R2 here plus that R parallel that we got plus the R5. See that? Which is equal to what is, I wanted to say R2 here. So what is R2? R2 is 8 ohms. So this is 8 plus 2,4 plus R5. What is R5 plus 10? What does it give me? This is RS for series. Alright, so when you add that, I think it must give me 8 plus 2,4 plus 10. So what? 20,4. So I've got 20,4 ohms. So far so good. Then we continue. We're not done. After I have gotten that, so now I've got a new diagram again. So this new diagram, pretend this one now is gone. See, everything I'm scratching out, it means it's gone. So this is also gone. All this is gone. We have all this is gone. We have a new diagram here, and that new diagram is like this. It means it comes from here, then from there, remember that other one is gone. I have got this, which is like this. That one is gone there, and then it continues further. Now meaning my I here is going to split into what? I1 and this I of the new R series that we calculated. Alright, but they are in parallel. So let's do that. That is now the final. Now we're looking at the last two resistors. We're going to call it R total, which is our R parallel, but is R total now, but is in parallel. So I must do the right formula, which is 1 over RT is equal to, but is our R parallel, right? Is 1 over R1 plus 1 over RS that we got. So 1 over RT is equal to 1 over 24 plus 1 over that one. What did it give us? It gave us 20,4. I'm saying that. Then from there, I told you, you say RT equal to, you say 1 over, then it's 1 over 24 plus 1 over 20,4. You see, that's how you do it, so that you don't make errors, but you must write it as RT. Now let's find the total resistance of that circuit. If they bring it something like this, you know how to deal with it. Now just remember, I'm going to do these again later when I look at direct current. Alright, so it's 1 over, and then it's 1 over 24 plus 1 over 20,4. Am I right? Equal to, then let's look at this, 11.027. So it's 11.027 ohms. This is the total resistance of this circuit. Let me erase everything into this thing now. That's the total resistance of the circuit. It doesn't matter if you had gone from, as I said, it doesn't matter if you had gone this direction like this, whereby you do this one to say I'm splitting here using the flow of electrons, not the conventional current. It was still gonna give you the same answer. Trust me, you can try it out. It will give you the same answer, because when you do that, these will split here. Still you are forced to focus on that. From there, you are going to go this route. From there, it will follow the same sequence. All right. So guys, this is what I wanted to bring to you. The resistance, and that module, remember, is under resistance, and this is Industrial Electronics N1, the ultimate guide. There are more modules to come. I don't want you to miss any of these modules if you want to prepare for your final exam. And also, let me give credit where due. These videos, as I said, are sponsored by Ekurhuleni Technical College, and it's a privilege to be sponsored by such a distance learning college, so that they enable these videos to come to you guys at no cost to you. So check their courses. You might be interested also in registering with them, and mostly they offer distance learning more than the full-time or part-time. So you can check their website and you can get more information. Now, what do I mean? In the next lesson, I need you to focus now. Don't lose me here. In the next lesson, what am I doing? Capacitors. You need to get hold of this. That is lesson or video for video lesson number 4. But of course, resistors is part 1, part 2. But this is now for capacitors. Remember, you just need an hour maximum to get hold of each and every topic. An hour will do. And trust me, you'll be ready for your exams. Now, join me in the next lesson where I do capacitors, and you cannot afford to miss out on this lesson. Thank you.